Okay, one last video for today. This is about the derivatives of the trig functions that we just spent a little bit of time on before school let out. So I'm going to show you how to derive the derivatives of tangent and secant. You should go through and try and do the same thing for cotangent and cosecant on your own. After that, we're going to do a couple of examples. So the first thing I'm going to do, and notice I'm still writing f of x because I haven't done the derivative yet. I'm going to write tangent as sine x over cosine x. Then I'm just going to use the quotient rule like normal. Now, since I'm taking the derivative, I write f prime of x. Derivative of sine is cosine x. Derivative of the top times the bottom minus derivative of cosine is negative sine x times the top, which is sine x, all over cosine squared x. Those two negatives become a plus. So this becomes cosine squared x plus sine squared x, and that's an identity. That's one of the big trig identities. Cosine squared x plus sine squared x equals 1. So I end up with 1 over cosine squared x. The accepted way we write this is secant squared x. So that's the way that I'm going to want you. I want you to leave it as secant squared x. Because when you go on to Math 160 or Calculus 2, you're going to be using that derivative and antiderivative a lot. Okay, next step. I'm going to do the same thing. I'm going to do the same thing with secant x. I can write secant x as 1 over cosine x. Remember, when I do the derivative of the top, the derivative of 1 is 0. So f prime of x. I'm not going to write anything else, because whatever happens when I multiply by 0, I get 0, minus derivative of the bottom. Derivative of cosine x is negative sine x, all over cosine squared x. So this gives us f prime of x equals sine x over cosine squared x. Again, that's not the standard way we leave the problem or leave the answer. We're going to write this as sine x over cosine x times 1 over cosine x. This is secant x. This is tangent x. So the accepted answer, f prime of x, is secant x times tan x. For the cotangent and cosecant, I'm not going to go through the process again. You could go through the process, but it's the same idea. So if f of x is cotan x, f prime of x is negative cosecant squared x. See, there's a relationship and a pattern there. If f of x is cosecant x, f prime of x is negative cosecant x cotangent x. But for what's coming up, these are the two that get used the most. So those are the two you should focus on remembering. The next step is then to use them using the chain rule. I don't want to just go through and derive everything again. So when I come to do the derivative of tan is secant squared of 3x. Then I do the derivative of the inside. The derivative of 3x is 3. I'm going to write that in front because it's more aesthetically pleasing. Same thing here. This is not a product. I have to take the tan of something. So f prime of x. This time I'm going to do it a little different. Remember I said I could start on the outside and work my way in? If I start on the inside, the derivative of 5x squared plus 3x is 10x plus 3. That must be in parentheses. That's the derivative of the inside, times the derivative of the tan is secant squared. This argument does not change. Final answer. Over here, if I'm going to do the same thing with secant, f prime of x, the 3 is a coefficient. It stays. The derivative of secant of 9x is secant of 9x, tan of 9x. The derivative of 9x is 9. The only thing I can do is multiply the 3 and the 9, and I get 27 secant of 9x, tan of 9x. Final answer. Last one, same thing. I just have an x squared plus 3. Parentheses are going to be very important. Just to kind of review, if I start on the inside this time, the derivative of x squared plus 3 is 2x. I'm going to write that out in front. Now I move to my outside function. Derivative of secant is secant of x squared plus 3, tangent of x squared plus 3. These are going to be really important coming up. We didn't get a lot of time to do them in class, so you should be practicing some of them on your own, and I will give you also some problems to do.